Good morning, everyone. And yeah, my name is Sergey. This is Adam and Eid with me today. And we will speak about lifecycle problem. So probably many of you attended yesterday at a Git talk where he introduced new architecture components. He introduced live data, Mutable, new persistence library named Room. And today we will focus on lifecycle part of these architecture components. So we will speak again about live data and Mutable. We will speak about lifecycle owners and lifecycle events that are basics for these libraries. But we will have more details. We will have some reasoning behind our decisions. So if you attended yesterday, it will be still interesting. If you didn't attend yesterday, we will reintroduce all of these things so you will understand everything. And so let's see what we have today. And today we have an activity in the fragments on start methods that not 4-line length, but dozens and dozens lines. And these lines are results of very natural process. Like Google Play services ask you to register them in on-start methods. Your own components need to know about these lifecycle events, so you need to forward them in some kind of API. And correspondingly, on stop method, you have to call all pairing stop methods. And it's very easy to forget one. And this will result in a subtle bug. It will drain a user's battery, and they will enjoy your app a bit less, which is probably healthier for them, but we think that's bad. And we think the answer on this situation is introduce lifecycle-aware components, so components which handle lifecycle. And the first step in this direction is to introduce lifecycle as a first-class citizen. So it's a very simple object which answers you on the question, what is the current state right now? And notify you about new events. And then note, which is important, but sounds ridiculous right now, events and states are different things. So let's see what I mean. Your activity is instantiated in initialized state. And all creation phases pass very routinely. On create, created state. On start, started state. Same thing for resume. But the row down is a bit more interesting. So on pause event leads you from resume state back to the started state, not to the new pause state or something like that. And the reason for this is, from a system perspective, the states after on-pause event and on-start event are the same because the sets of the actions that you are allowed to do is the same. And the same is true for on-stop and the created state. And the last event is on-destroy. It's pretty straightforward. It brings you to destroyed state. Your activity is destroyed, it's going to be thrown away, and garbage collected. Well, so let's make our component lifecycle aware. That's super straightforward. We tag it with lifecycle observer interface. It's empty interface. To get actual events, we add annotation and pass the events that we are interested in. You can pass multiple events if you want to. Last step is to add ourselves as an observer. And we may have a potential problem here. What if an activity is already started at this point? Does this mean that we are going to receive on-stop event, and we didn't receive on-start? And our component probably is not ready for this. But we took care of it, and we bring the observer to the correct state. So what does this mean? Let's take this example, which I just discussed. From activity perspective, on start and on create already happened. And after that, we add an observer. But observer will still receive on create and on start events, like immediately when they were registered. So let's take one step further. On resume, same situation, resume state. We bring to resume state. We got an on resume event in addition to on create and on start. A bit more interesting situation. On pause. In this situation, we are in a started state as well, as we learned. So we bring the observer to the correct state, which is started. So it's a similar situation as we had 1 minute ago. observer will receive onCreate and onStart events. And that's it. So we don't have a problem in this code. So how to get this magical lifecycle object? We have this interface, which is super simple, but this probably doesn't help much right now. And the actual question is, who are lifecycle owners out of box? And answer in this question is support library, fragments, and support activity. But unfortunately, this is true only in bright future. And right now, we have lifecycle activity and lifecycle fragment. But at the point of 1.0 release, we will merge our library to support library, so you don't have to use them later. And now Adam will speak about some key difference between fragment and lifecycle observers.
So if you've been following along, you probably recognize some similarities with the Fragment API in this as well. So at this point, we've got these two different components. Which one do you use? Well, as the slides are already spoiling for you, this really isn't an either-or question. One of these things doesn't necessarily replace the other, and here's why. Fragments, on one hand, that everybody knows and loves, right, are statefully managed and recreated after either a process death, an activity recreation, or recreation of any host that you have the fragment within. Fragments manage views and also interact with the navigation stack, which are things that are firmly out of scope of what lifecycle observers are meant to do. Instead, lifecycle observers are meant to enable more granular factoring of your code, whether you're in an activity or a fragment. They're stateless, so that means that they must be registered each time the owner is recreated. We're not going to try to recreate these magically for you. They don't have any concept of instance state that they carry around with them. So these are meant to be very, very lightweight so that you don't have a whole lot of additional management overhead. And last, there's no relation to the view or navigation management. These really are meant to be very tightly scoped, isolated components. So they can really help everyone. It means that it's much simpler to integrate libraries with your code, as long as those libraries have provided lifecycle observer-aware components. It means that you can break up those really large fragment or activity classes to make them much simpler to understand for a reader. And you can provide much more granular guarantees around what operations are valid at any given point in time. You can make it so that if an operation happens, then you're guaranteed to be in a correct state when something is called. So lifecycle owner, as already introduced, is just an interface. Anyone can implement this. This means that you can improve testability by creating your own. You can create your own sort of fragment-like library implementations if you feel so inclined. But you can also create composite lifecycles, lifecycles that span across other smaller lifecycle definitions. So you can answer questions like, is my app visible? So this is a really common composite lifecycle that many of you may be interested in. It lets you do things like session management to track a particular session across perhaps some sort of a flow or a series of logged in versus logged out events. And it may help you with analytics as well. So we have the process lifecycle owner as kind of a component that I think a lot of you will be interested in for this. It's the composite lifecycle of all the activities in your app. So there's no configuration changes to handle because we're not going to be dealing with those from these. The process lifecycle owner just stays alive through the whole process. But that also means that you don't get state restoration after process death, like we mentioned earlier. So that means that you don't have to handle saving and restoring that state, but at the same time, you need to remember to re-register these process lifecycle-based observers if that's something that you're working with. So many Android components provide a lot of kind of deep plumbing layers for things that you can plug into and work with. But a lot of times, we've kind of omitted the idea of higher-level components that make use of that plumbing so that you can just plug, play, and go. So, I mean, do we have anything more high-level than the bare events and states here?
Maybe we do. Let me show you.
Great.
Thanks, Adam. So it's so nice. Now you can observe a life cycle. It's well-defined. It's a first-class citizen. But you still need to deal with these things. And we thought, like, OK, there's some common lifecycle problems that we should be able to solve with these components. So we look at the problems that people are having. And this was probably the most major problem we have been seeing, the untimely UI updates. It's like when your activity receives a callback, but the activity is already stopped, it tries to start a new activity and crashes, or it tries to add a fragment and crashes. If an activity or a fragment is stopped, there is no reason to update that activity, right? You don't want to do that. If the activity happens to become visible again, then you want to do it. So we realized that this is a very common problem, and we wanted to solve this with a higher level component, which we call live data. Now, we'll look at the live data in detail. It's actually an observable data holder. It just holds on to some information that you can observe. Now, the difference between live data and your other observables in data binding or RxJava or whatever is that live data is lifecycle aware. It knows about Android lifecycles, and when you want to observe a live data, you can pass in this lifecycle so that it can manage your subscription. The nice thing about live data is that you observe, and that's all you do. So we'll look at a usage example. Let's say we have an activity, we receive a live data from somewhere, doesn't really matter, and then we call observe on it. And when we are calling observe, we are passing this, which is the lifecycle owner. That's all you need to say. I want to observe this live data within this lifecycle, which also means if this lifecycle is gone, I don't want to observe it. Or if this lifecycle is stopped, I don't want to receive events. And then once you do this, that's all you do. You don't need to write on start, on stop. We want Android development to more look like this. You initialize things, it's more like fire and forget. You initialize, and you are done. So let's look at what happens when our activity starts observing that live data. So on create, it called observe. We said live data is observable. And as soon as activity starts, it starts receiving data changes. So whenever the live data's value changes, we dispatch that event back to your observer inside the activity. It can also be a fragment. Let's say user decides to rotate the activity at this moment, so you know that the activity will be stopped. And what happens at the same time, the live data happens to be updated. If that happens, we are not going to tell the activity about this change, because there cannot be any reason for you to update the UI because it's already stopped. Similarly, if the activity is destroyed, we will automatically remove that subscription because that activity is gone. We know about it. There is no reason to keep a reference back to that activity. Now, we said the activity was rotated, so you know that Android is going to recreate that activity. And then we are observing the same live data back. As soon as the activity starts, it's going to receive last available data. So your UI is going to have the data before it gets a chance to draw. So similarly, let's say user hit the home button, which means the activity will be stopped. Again, if the live data changes while the activity is stopped, it's not going to receive any events. Even if the data changes, we are not going to tell it. But as soon as if the user comes back to the application, we will give it the last available data. So this is why we call live data is not just a stream of events. It holds on to the data so that if a new observer comes, it receives the last available value. And then eventually, the user backs out of that activity, and then we remove that subscription. You can also extend the live data class. When you extend, because live data provides two very handy callbacks. The first one is called onActive, which means you have an active observer. And the other one is called onInactive, which means you don't have any observers, so don't bother changing your value if it is something that you care about. You probably ask now, what is an active observer? Active observer is an observer whose attached lifecycle is started or resumed. So it's like a fragment that's currently visible to the user. If the fragment is on the backstack, the user is not seeing it, it's stopped, so it's not active. There's no reason to do any work for that fragment. Let's see how we can take advantage of these new callbacks. So we are going to create a new location live data class, which represents the location of something on the device. So we say this data holds an instance of a location. In constructor, we just get the location manager from the system service. There's nothing fancy here. And we have a listener. Whenever the system service sends us a new location, we just call set value on us. That's all you do. There is no lifecycle handling here. You just call set value, and live data takes care of handling the lifecycle. And you may have any number of observers. It doesn't really matter. So we want to override onActive, right? The very first active observer comes, we want to start listening to the system service. Similarly, when the last active observer goes away, we want to stop observing the system service. Now, if you look at that location live data class we just created in the previous example, let's look at the properties of that class. First of all, it is lifecycle aware. It knows when to start itself, when to stop itself. You just don't need to babysit it anymore. It is self-sufficient. Like, you start it, you forget about it. It can even be a singleton. Like, all of these subscriptions are automatically managed for you. So if the data is logically singleton in your code base, you can make the live data instance singleton. So there's this thing where, like, normally if you keep a reference to an activity or a fragment from a static context, that will be a big no. But if you are using live data, it is yes, yes, because we manage the subscription for you. So you also don't need to subclass in live data all the time. So if you just need an instance of it, but you already have the value, you can use this mutable live data class, which comes inside the library that has a public setter. But usually when you are using this class, internally you will have it, but the API you expose will just return a live data because you don't want to expose the fact that anyone can set the value on it. Now, when we were designing these lifecycle components, the live data, actually we spent a lot of time to get rid of one exception. This fragment exception that I... we really wanted to say, please, no more fragment transaction exceptions. So live data guarantees that if you received an event, you can run a fragment transaction. And to see how we are making it part of the history, I want to invite Adam back to explain it to us.
All right, so anyone who's received one of these exceptions realizes that it doesn't just come from trying to do something when you're just completely stopped and you absolutely know it. These exceptions tend to come in when you get into very intricate nested life cycles. So we wanted to make sure to be very thoughtful about defining how the lifecycle observer callbacks are invoked and when. So in a case like this, what happens? You have defined handler for the stop event. So in the container, your activity on stop, you want to make sure that you don't get an on changed event after the on stop has happened. But in order for that to happen, what needs to be true about when we actually invoke all of the on-stop listeners and that are attached to these observers? So we have to define a really strict order for this. So as we go through create and start and on resume, we know that we need to invoke the lifecycle observers after the container event happens. So you know in your observer that everything about your lifecycle owner has been configured. If you check any state about it, you know that you're already completely in that state. But that means something really special for coming back down the other direction. It means that when the activity starts to become paused, you want your lifecycle observers to be able to shut down anything that they're doing before the activity does all of the work to actually become paused. Similar for stop. And this is where this becomes really important for the fragment transaction exception. You want to make sure that you're recording that you're fully stopped before the fragment system goes through and flags everything as being completely locked out. So what that means is that the stop event of your lifecycle observer will always be invoked before the activity on stop or before the full stop event for your container happens. So this seems really similar to some other libraries that some people may have seen in the past. Can you talk about that?
Yep. Yes. So when we create new observable pattern, like nowadays, this question is unavoidable. Is it in another Rx Java? And the answer to this question is yes, because we want to promote the reactive programming model, especially when it comes to relationship between your UI and the state of this UI. We want you to react on the changes of the state. So it means that it's a reactive programming model. But on the other hand, no, because it is lifecycle aware out of box. as Git mentioned. And it's much easier. As many of you may know, learning curve of RxJava is super steep. And if you have an Android learning curve, and after that we add RxJava learning curve on top of this, it becomes very hard to new people to start to develop on our platform. So we just can't just say to them, like, oh, let's go, just learn this, that's it. No. So, but if you already learned RxJava, we don't expect you to migrate from it to our solution, because you already passed this learning curve. You and your coworkers are comfortable with it. Fine. We are totally fine with this. But one thing we ask you to do is to be sure that you manage lifecycle. RxJava has common approaches to solve this. Be sure to use it, and everything will be fine. But when you start a new app, we think that this model is the best. The best is to start a project with a live data, because it's simpler, it's faster, it's lightweight, it's well integrated with a framework. And if you feel like you love reacting programming a lot, you want to bring it not only to relation between UI and state, you want to bring it to your business parts of your application, then you may consider addition of RxJava, because it gives you like more power. And we will actually help you to do that. We have this extension to our library, which gives you the possibility to create live data from publisher and create publisher from live data. So this integration should be quite smooth. But I want to highlight a key difference between RxJava and live data. So as Eid already said, live data is a holder, not a stream. So we have a reference to the last value, and observers immediately receive the last value when they start to observe live data. Another big difference is the threading model. As you know, RxJava has a very sophisticated threading model. It's extremely powerful, but in most cases, you probably don't need it. And we have everything on the main thread. And the reason for this is we want to give you all these guarantees about when we will notify you about state changes. So, and we can't do this on a background thread. We have just one exception. We have a post value method, which just utility method, which trampoline value from a background thread to the main thread and set it there. It's super simple. So quick summary of what we have at this point. Lifecycle events, observable pattern, which respects these events. But there is one big thing which is not covered yet. And this is how to handle configuration changes. Yep, in 2017, like almost 9 years after Android was first time released, we still discuss this question. And this is a total legit question. And we hear it constantly from new Android developers. Many of you probably know what's the deal with it, but let's take a look on this oversimplified example, but still very vivid. So you want to show this information about user and your activity, and you want to make some web service request. We will use live data to get this result. It's super simple. When the request just started, it's empty. When the request response is received, we put this it to live data as a value. And live data will update our UI. It will notify activity, and it will done everything it needs. So what happens if activity is going to be rotated? Yep, we're going to make it call twice. And I hope that you don't call web service right into your activity, but you probably have some abstractions, and you need that does something like that, which goes to a network, which go to, I don't know, caching and persistent storages. And all these operations are asynchronous by nature. So communication with these components are asynchronous. And you probably don't want to make these calls twice anyway. So what you want to do is to cache this user data, like in our example. And what are the ways today to do that? Well, one of the proposed ways to do it is a fragment.setRetain instance. And it can rant about this for hours. Unfortunately, we don't have a time for this today. But I just say, like, the only fact that you have to run Fragment transaction is terrifying for a lot of people. People go nuts. And another possible way to solve this is loaders, but they don't fit here well as well. So we decided to tackle this problem once again and create viewModel. So what is this? viewModel is an object associated with a fragment or an activity, but is retained during configuration changes. So its scope is a kind of a logical scope of your activity. So what does this mean? Let's see. We have an access time and a current moment, and we can predict the future. And we know that an activity is going to be created, and this means that all constructions events are going to happen. During onCreate, we will request viewModel for the first time. We will create it, and after that, this activity just uses this viewModel. Pretty simple. Now we predict that activity is going to be rotated. Let's see what's going to happen with our viewModel. We will receive events, this pause, on stop, and on destroy. But when all these events occurred and your activity is destroyed, is thrown away, and it's garbage collected, viewModel survived it. And the new activity, which was created in place of the old one, uses the same old object. So you can easily cache their live data as we want to, or something else. In the last case, what is going to happen if we have a finish call? Once again, we will receive these destruction events, but this time, viewModel is available until onDestroy method. During onDestroy method, we will call onClear on it, which notifies you if you have any currently running actions or any resources, it's time to close. And after that, it's going to be destroyed and garbage collected as well. So at the point when your activity is destroyed, it's not going to be recreated again. Your viewModel is gone as well. So let's quickly make our sample in viewModel. So we start with instantiating, with creation of a viewModel class. We want to cache the user data. We create a field for that. Our activity needs to access this live data, so we create a getter for this. And finally, getter is extremely straightforward. If we already requested the data, we just return it. If the data is null, OK, we request it from a web service and returns it. Fine. We had this code in our activity. Now we need to get this live data from viewModel. To get it, we need to get viewModel somehow. So this is how we do. Let's take a precise look on it. First of all, we need to get viewModel provider object. This is an object which is associated with a fragment or an activity. It knows how to get already existent viewModel from it, or how to create a new one if there is no existent viewModel. After that, we request our myActivity viewModel. And later, everything is quite simple. We get the user data, we observe it to update the UI. Fine. So what are the rules of usage of viewModel? So viewModel manages the data for the UI. It means that it speaks with business parts of your application to retrieve the data. So it may be repository pattern or any other pattern that you use. It forwards user modifications back to these components. Another good case for viewModel is acting as a communication layer between fragments in one activity. And it will speak about this a bit later. But prior to this, things that you must not do in your viewModels. So first of all, you must not access views and any other UI-related entities. The reason for that, they are going to be recreated during configuration change. If you try to use them, you will either use stale data from there, either leak them. It's like, that's going to be finish bad. And it's Fragment or Activity's job to bind the data that you will get from a view model with actual UI, text views, buttons, I don't know what else. And one more thing, there are resources which sounds more harmless, like strings or drawable. And you may think, I may cache it here. No, they depend on current configuration state as well. So yes, right now you may have just one resource for every configuration, but later you will add the same resource for a different configuration. You will easily forget to update your view model. So, and you may not notice this, but your users will see the invalid UI, and this is just ugly. And now, it will speak about inter-fragment communications.
So I want to talk about one of my favorite features about vModel, which is communicating between multiple fragments of the same activity. So it's got a UI like this, like the Gmail on a tablet, where on the left side you pick an email, and on the right side it shows the contents of that email. Now, usually you will implement this as a fragment on the left, which picks something from the list, and another fragment on the right, which shows how to show the contents of an email, so that if you're on the phone, you can reuse the same fragments, but separate from each other. Now, if you ever try to write a UI like this, if you ever try to make these two fragments talk to each other, it's a pain in the neck. It's very, very hard. Like, you need to create an interface, but then what if one fragment gets created before the other one, then the activity needs to talk to each other, or like when the activity is restored, you don't really know which fragment will be restored first. It is really hard to manage this state. But we can actually solve this very elegantly using a vModel. So let's say, these two fragments actually want to talk about a selected email, right? This is the information they want to share. So let's put it inside a vModel, and we are going to call this shared vModel. So it has a mutable live data inside it, which you call selected, and it provides two very simple APIs. The first one says, set the selected email to this email, and the other one says, get the selected email as a live data. So very simple vModel. But now once we have this, let's go back to our fragments and see how we can use this. So inside the content fragment, which is the one that wants to display the contents of the email. So it wants to know when the selected email changes, right? So we are going to go, so we have already seen this. You can go to vModel providers class and get the vModel providers of this fragment. But we actually want the vModel not from this fragment, we want it from our activity. So all you have to do is tell it to give it from your activity. Now it's going to return you a vModel in the activity scope. And then we say get for the shared vModel. Now the very first time one of the fragments called this, we are going to create a new one. When the other fragment comes to life, it's going to receive the same vModel instance. And then you do the same thing. So this one says get the selected email, start observing on it. Very similarly, in the selector fragment, which was the one on the left, where user picks an email, we get the same vModel. And then whenever the user selects an email from the list, we just call the vModel's related method to change the selected email. Now, these two fragments talking to each other without actually talking to each other. How does it really happen? So if we go back to our UI, so we have the selector on the left, the content on the right. But if you look at the details, actually both of these are talking to a shared vModel. They never talk to each other. The beauty of this solution is that if you are on the phone, let's say one fragment replaces the other one, there is no room for error. Like, the fragment still talks to a vModel, vModel is always there, nothing will crash. They don't even care the other one is there. OK. So this was a lot of information, and there's like further details about how these life cycles work. We really spent a lot of time to make these like handle the most common use cases on Android. So we recommend you to first try it out. You can try it now in maven.google.com. Please check out all of the architecture components. These are things that actually work very well together. We have an architecture guide which shows you how to use these things together to write a good application. And also check out our code labs. We have code lab sections at I/O that will give you a first glimpse of how lifecycles work. Thank you.